So we, after ChatGPT came out last year, by end of November, there's this huge growth of interest in large language model. So first I want to introduce what is exactly large language model, and that gives us a context of all the technology surrounding the large language model. So if you, ChatGPT is a black box. You talk to ChatGPT, give you response, and then it can do magic things. It can do coding, can answer questions, summarize your book, give you conversational answer, write poetry, write blogs, all kinds of tasks we can do. So the whole thing is very magic. But essentially, what is ChatGPT? What is the large language model? Is essentially it's a deep neural network. So if we go to the essence of what a large language model is essentially it's a deep neural network that takes a question, give back a response. So if you build any application around this model, basically you want to think about what are the properties, what is the input I send in, what is the output I'm receiving back. I don't have time to go into the whole. I have actually a training class on this, but essentially a large language model is not just a deep neural network; it's also pre-trained. So the fundamental concept of large language model is it carries a lot of knowledge. The knowledge is the whole internet. So it has to be pre-trained in order to be considered as a large language model. For example, if you take a Llama 2 from Meta, that is a pre-trained model. But if you just take the original transformer from back in 2017, doing Google translation, that's not a large language model. So by definition, large language model has to be pre-trained. So that's the second. Certainly is it has the property that once you use it, you can give it a variety of tasks and adapt that to your local domain, like medical domain, HR or IT support, all kinds of domain. All you have to do is add a prompt, add some document local instruction and the document, and it can do somehow just adapt to that. So we will, why it can do that? There's a lot of research on that. It's not the focus of today.
You're fine. Go ahead. You're fine.
Next slide. All right. But I want to just bring to your attention the basic architecture of a large language model. Is the reason we have to understand this basic architecture is because all the embedding, all the vector database, all the improvement on top of what you build is related to this architecture. For example, at the bottom, the input is text, text authorization embedding. So when you build a local document to retrieve, it has to formulate in the same format where the original GPT, Llama, original model, the input format has to be identical. So that is the fundamental part. And the inside is the transformer architecture. So whether it's BARD, whether it's Llama or GPT, they actually have identical architecture. It's all transformer decoder only architecture. There's no encoder, so there's no longer BERT architecture inside. BERT was very popular for a long time. But what people realize, you can simplify the architecture, just use the decoder side. We won't go into detail of why that is the case, but essentially in this architecture, there's two major concepts. One is attention layer, so the attention actually attends to the document, and then there is a feed-forward layer. And then you stack this layer on top of each other, duplicate many times. So for the first GPT is 12 layers. For GPT-2 is 48 layers. For GPT-3 is 96 layers. And for GPT-4, it's much more, right? So we don't know. They never released their data. But we do know it's 10 times of the GPT. The number of parameters of GPT-4 is 10 times of GPT-3. So that understanding what's inside the typical large language model will give you more power for you to, in the future, to adapt or even modify doing fine-tuning of those models. Next. All right. So I want to give you a quick overview, quick historical overview on how this large language model paradigm evolved. Back in 2017, when transformer was invented, and the same year PPO, the reinforcement learning method, was invented, the people start to see the power of having this architecture trained over the data, and it simplifies the processing of a text document. Before that, the people use a recurrent neural network, which allow you to capture the sequential information. But a transformer also captures sequential information, but it doesn't use very complex recurrent neural network. It's a simple feed-forward neural network. It's easier to train, easier to parallelize. That what it is. No, not to the next. With transformer architecture itself, it's nice, very good, interesting framework. But the main power comes from pre-training, which is GPT. What did GPT propose in 2018? So GPT is the first paper that showcase that if you pre-train the model on large collection of data, originally was on 7,000 books, it has much more power to do additional tasks. And then GPT-2 added that book on top of books, a collection of web texts. So a lot of internet documents, and then it shows that now you don't even need to do fancy domain adaptation. So in GPT, the first GPT paper allow you to fine tune on your local data. So you take a GPT and then fine tune, get a lot of local training data. But the GPT-2 showed that without local training data, you just add a few examples. So they call it a zero shot or few shot learning, where you don't need much additional data. So that's the power. People start to see the power. By GPT-3, GPT-2 has a 1.5 billion parameter. GPT-3 has 175 billion parameter, which is 20 times more of GPT-2. And by GPT-3, people realize prompt engineering becomes the key to enhance the performance. However, not until instructed GPT, not until we can do reinforcement learning on top of GPT-2 model, the performance of such a large language model is still not satisfying. So if you compare the GPT-3 output versus instructed GPT, which use the human feedback to tune the model, the GPT-3 at below 2, like a human score from 1 to 7, GPT-3 is around 2, but the instructed GPT immediately jumped to 5, and that's a huge jump. With that jump, now it's doable. It may be the practical that you can actually use for practical purpose.
Yeah, that's even better.
Sorry for the interruption. Anyway, so instructed GPT demonstrate with reinforcement learning, human feedback, you can dramatically improve the performance, and that make it practical. That's where ChatGPT is based on. So ChatGPT is called the GPT 3.5, meaning it's building. It's built on top of GPT-3. Add the instructions, fine tuning of that. And then GPT-4 just make it large. GPT-4 just essentially has much larger models, allow you have more parameters, more training, and more training data. after GPT-4, which in the same year, March this year, the BARD was released. And then now we see Llama 2, and so we are in this kind of race toward the better and better foundation. We call this foundation model. And in the meantime, people started to see application to build on top of them.
Right.
Yeah. So how do we build a LLM-based product? In classical sense, essentially, LLM is a machine learning model. Machine learning model can be based on other machine learning model based on deep neural network. So deep neural network is certainly one type of machine learning method. However, it makes it dramatically different from traditional machine learning model. In classical sense, when I work at large companies like PayPal, Samsung before, we build a model for predict user customer sentiment, build another model based on the data to do customer support, build another model to understand the HR document, and then build another model to do to predict the user preference, do recommendation. So you have data, then you build a model, then you save that model somewhere. With the large language model, the paradigm shifted. Next. So now we no longer has multiple models for different tasks. Instead, it's one single model that can do all different tasks. All you have to do is give it instruction. Say detect the user sentiment, followed by the user input. Or to answer user question, followed by whatever document you have. And also you can do you can process HR document, you can process all kinds of documents. And so this is what we call instruction tuning, where you give instruction, you tell the model what to do, it gives you the desired result. So this is, of course, it's very magic. This property arrived, people first realized it from GPT-2. The GPT-2 paper, people realized when they trained the GPT-2 model on the internet text, they didn't train specifically, say, translate from French to English. They never give instruction. All they did is just feed the internet data to the model from beginning to the end. So they do auto-regressive training, where you have a sentence from the article, the first word predict next word, the first two words predict the third word. So you continually feed the whole document, doing auto-regressive learning to the model. And when you finish training, somehow, when you say translate French to English, you then followed by French, the output will be English. So this is we call emergent property from a very large data set, because in the internet data, the model has seen probably whenever they see the word translate from something, and they always see this one language followed by another language. So somehow the model arrives at that property. It understands how the model connects to each other, how the instruction connects to each other. So for example, if we say, behave like a health coach, tell me what to do, like to lose weight. Maybe somewhere on the internet, there are thousands of documents claim themselves as a health coach, then there are instructions after that. So it's all from the training data. But that gives rise to this specific paradigm where we use one foundation model to build all the applications. Next. So the way we build application for the so-called LLM-based product, we certainly have a user who have a use case. The user could be interested in some email assistant, could be blog writing, could be customer support. So depending on the use case, you have different applications. So this application essentially is sitting on your server, talk to the listening to the user request. Now, the simplest way to build application is you directly call ChatGPT to return the answer. So you act in the middle. What you do is you send a prompt, say behave like a health coach, and then followed by the user request. Then the answer you query, you send the request to ChatGPT. ChatGPT give you back the answer. So you basically build a layer on top of ChatGPT by figure out your specific domain, your specific application. So that's the simplest, easiest LLM-based application anyone can build. But certainly, if anyone can build, there's not much competitiveness in your product. What people realize is, on top of that, you probably want to incorporate some domain knowledge. For example, if you have several health coaches who have written many articles, and you want a specific advice from those coaches, then maybe you want to incorporate their article on top of the ChatGPT answer. So the question is, how do we combine that information together with the ChatGPT answer? The next. So here, I just want to add what I said earlier. How do we do prompt engineering? So if you, even before incorporate additional document, the prompt engineering certainly is having the good instruction to the large language model. And then the best, what improve the quality is to give a few examples. The examples makes big difference when for the answer comes back. And many of you probably have a lot of experience fine-tuning, playing with those prompts. Now, so the I will come back to how we do the local document learning inside of local document. But just on the larger side, in the backend for the large language model, there are many options. We have for Llama 2 that you can download as open source. You can train, you can host that on your own server without sending your data out to ChatGPT. You can use a BARD API. You can use Cloud 2 from Anthropic. So they also have a large language model. So you all these options. So some are hosted remotely, some are hosted locally. There's a pro and a con. So if you send remotely, your data is sending out. So if you are a large enterprise, you worry about the sensitivity of your data, the privacy. You don't want to send all your customer information to the internet, to some other company. So then you want to host on your own server. However, if I actually gave a tutorial on Llama 2, is if you just look at Llama 2, the smallest model is 7 billion, the largest is 70 billion. Even the 7 billion model, you need 28 gigabytes of RAM, GPU RAM, to just load a small model. And for the larger model, so for 70 billion, you need 280 gigabytes of RAM. And very few companies can afford these many GPUs. When you run the GPU, they are very expensive. So you have to consider, if you host on your local premise, what's the cost? How can you make sure you have sufficient resource to run this? And also you want to make sure the accuracy is good. So sometimes you sacrifice the accuracy by having a smaller model, but then it's only 50% accurate, whereas the 70 billion model is maybe 79, 80% accurate. So this is 50 was 80. That's a huge difference in user perception about your performance. And so that's a big issue, how you can fine tune existing open source model to host on your premise. And there's a huge, there's a lot of research going on that. So that part, but on the other hand, if you send, you can of course still use ChatGPT, which they're trying to lower the cost, and maybe send some not so sensitive data to them. And with also competition with Bard, with other company, the cost is not that high so far. But there's another issue sending out is the speed, because when we actually experiment, sometimes it takes 6 to 9 seconds for the answer comes back, and that really impacts the user experience. So, and when the ChatGPT has when the OpenAI has a lot of requests to the server, the speed cannot be guaranteed. And so then you have to figure out whether you have an enterprise solution or a different plan with them, or paying more price, paying a higher fee. So all those are concerned. So this part is a very important part to decide if you want to build your LLM-based product, what you need to do. Now the second part is about the how you load your local document to combine with your to send it to large language model. So for example, if you are building an insurance application, life insurance, not necessarily life insurance, but the general insurance question answering application, you probably have a lot of insurance documents. Then you want to user query comes in, say what would be the best life insurance for age 35, right? So with that question, you can find the relevant document first. And so maybe there's an updated document for people who are at age 35 for this specific insurance company. So you want to add that, and then combine that in your prompt, send it to your large language model in the backend. And so, as you can imagine, there are many ways we can store all these documents. So here, what I'm showing here is how do we store our local documents, our local knowledge base. So your local knowledge base can be stored in a file format. You can say, I have many text documents. Now I want to retrieve them. I think the next slide I'm going to show. I'll come back to this slide. So this comes back to the vector database concept. Before I introduce that, I want to first introduce how we represent the document, how we represent the input to the large language model. So if you think about large language model takes the sequence of words, each word is represented as a vector. A vector may be smallest 768 elements wide. Now it's 4,000 long. So basically, it's a vector of numbers. We call dense vector because it's still smaller than the total number of vocabulary. The number of vocabulary typically is set at 50,000 today. So your dense vector that represent the word is maybe only 4,000 long. We call this a vector, a word vector. So word vector is equivalent to, say, word embedding. So word embedding is the same term as a dense vector for word. Yeah. So this is the original. This is to introduce the word vector. Why we want to use the word vector is it gives us information about the relationship between words. So over time, the large language model is learning about the relationship between words. When we finish learning, we know the certain words are much closer to each other just by looking at the vector distance. So we know love has farther distance from a fight than kill. So this is just one example. Yeah. So next. Yeah. And then we decide, so this vector size, how large should it be? This vector is purely decided by the engineer, by the data scientist. So you decide how large your vector you want to be. the larger, the better. But the larger, the more computing you have to do. Your model becomes much larger. Each round, each instance is larger. I'll answer the question at the end. So okay, so this is a quick introduction to word vector. Next. Yeah. Now, how do we match a document to a user query? So if you think about all the documents you have in your database, you essentially converting a document as a sequence of words, and inside your collection of document, like insurance policy, you have many paragraphs. So what we do is we take every paragraph and send them through a large language model. This model may not be the same as the one that generates a response. In fact, you can use a much smaller model here because all you care is converting a document into a vector of numbers. So our goal is to use a large language model, take a sequence of tokens, convert it back to a vector. Basically, we use the way large language model works is if you say that my output is one single token, this single token essentially has identical size as every input token. So if regardless how many tokens you have in your input, but each time when you generate the output, you only generate one token. So what we somehow in a certain language model, you can take a sequence of words and give you output, give you a token output, and that output is the it's a vector of the same size of each token here, and we call that embedding for the document. So you can think about it more. That token is a summary of this whole document. And why that works? There's a lot of. I won't go into detail, but this comes back to how the model is originally trained and how we can actually condense the knowledge of the whole input into one single token. So this is the very fundamental property of a large language model is, remember in the early days, I would say 10 years ago, the way we summarize document is we have to add up, do the average of every word in the document. So we take each word in the document. We basically gather the word vector for every word, and then we do a average number corresponding elements, right? So we do an average of every word. That's a very simplistic way to represent the document. But here we don't have to worry about how we add up the words. We just send the whole sequence to large language model, and the output will give us the condensed summary. So essentially, this single token output is a summarization of the whole document. And then we save this vector, which we call embedding. So we save this embedding as a representation of the document. And that is what goes into the database. That's why we call vector database. So the vector database saves a single token embedding for every paragraph that you want to retrieve. Okay, so that this is the essence of why do we use a vector database. So now have to next. Yeah. So now how do we do retrieval? Once you convert every document into a single token representation, it's very easy to calculate the distance between two vectors. So your input is the whole question. You actually summarize you also send the question into the large language model. It comes out as a single token as a vector. Then inside all your collection of documents, you take every paragraph and calculate their vector. And if you find like a paragraph 1 where this query has the shortest distance with cosine distance, or you use other Euclidean distance, you can use different kind of distance measure, but essentially you are calculating the distance between two vectors. So the shortest distance is the most similar documents. So once we process essentially you go through every document in your collection, finding the distance between that document and the query, you then maybe end up with top five documents to use. Now, after this, I'm going to use, then I'm going to recover what's original in the document. So for example, I have 5 insurance policy paragraphs. So once I find paragraph 1, 10, 11, I might process the paragraph to the question. I'm going to recover original words. So I go back to the index, finding out what's the original text. And then add those texts on top of my prompt, the prompt plus context, and then plus the user query. You send this whole thing to the ChatGPT or send this whole thing to your large language model. And this is how you implement, we call retrieval-augmented generation. So the response is augmented by the context you receive. Okay. Maybe now it's a good time for questions. Yeah.
The context you get back is in text form, right?
Yes. Yeah. So because everything you send to ChatGPT is text. So basically the way you formulate the request is behave like insurance agent, and here the context. So you actually concatenate all the retrieved paragraph together, and then say here's the user question. So you add them all together, send it to, and then it comes back with answer.
So the maximum text size input, right?
Yeah.
How many tokens that's down to the database?
So the larger the better. If for example, now they can take 4,000 tokens in the sequence. So you probably want your context to be 3,000 plus your prompt. But it's also expensive. Yeah.
Microsoft Cognitive Search will go up to 12,000 tokens. No.
Or does 100?
Yeah. Llama code Llama can do 100.
For the embedding or for the discussion dialogue? I think that's probably for the discussion dialogue. He was asking about the embedding side.
Interrupt, but just to let people know there's a BMW i3 out there with the lights on. If it's yours, you might want to turn them on.
So,
yeah.
Why do you think that despite this large language model database, Google is still presenting more relevant search results? At least when I search on Google and Bing results just not
Yeah, that I don't know how they self do that. So Google has a BARD, right? So Google now is trying to incorporate the large language model. When you search, they have a different team. So one team handles large language model, one team handles, and if they're not confident, maybe they bring up the large language model answer from the other team.
And the second is that model you have, it has a domain training problem. Can I train my model on technical data and casting data?
Sorry.
So if I have
You could ask it, it wouldn't be useful.
right, okay, so it's not going to correlate across the domain. Very training data.
Training data set is your domain data. Yeah, that's right.
But the prompts are directed to the large language. They're not prompts are not directed for the
Prompt is your own prompt. You design the prompt. Yeah. And so there are also, you can let a ChatGPT generate prompt for you. So there are a lot of work going there.
So let's say my organization presenting a customer service problem.
Yeah.
We don't have a textual representation, but we have like a workflow representation in the images. How do you use these models to read those images and then probably prepare the LLM?
You can still use the image. Image can be transformed into tokens by vision transformer.
Okay.
So your at the bottom the language model you are using is a vision transformer.
Okay.
So the output from this image can still be a single token.
Be sure to repeat the questions for the people
So
that remote.
the question is, if we have an image in our domain data, how do we represent that? How do we use the image as context? Well, what I was saying, you can still represent an image or similarly as a text. So there is a vision transformer converting any image into a sequence of tokens. And then your language model is able to summarize that into one token. So it's used in the same way.
What's the challenge with all the conversational work?
The challenge?
Challenge having all 40,000 words.
Oh, it's just a computing challenge.
Memory or
It's also sparse representation. You don't. So that's different from today's talk. So that's a question about whether use a word index to represent a word or use a dense vector to represent the word. So if you have a vocabulary 50,000, you can use a 1 hot representation, right? You can say the word love is index 11, the rest are all zeros. That's we call one hot representation. But if you use one hot, every word is disconnect, right? Every word occupy an index in the vocabulary. So you have no correlation between words. And that actually remove the relationship between words. That's not what we want.
I was going to say, Word2Vec was doing entire words, but ChatGPT 4 and Llama 2 are doing like 2-letter pairs, 3-letter pairs, very short. And so the embedding is on a smaller character set, or like the Spanish enya will be its own character in a tokenizer for ChatGPT. And then, so then they get put together in the large language model. And then you can have much larger vocabulary that could be specialized to medical or other jargon in the large language model. You just have smaller tokens going in.
Okay. It's a distance. Maybe the antonym maybe is together. So for example, the enemy friend may be very close to, because they always happen at the same location in the sentence. So the what relationship is discovered through mining the internet text. And that's what's powerful about the user dense representation is you learn, you don't predefine the word vector. So word vector is learned through training, through the GPT, through pre-training. And that's what's powerful about having the dense vector representation.
Yeah. We have a question on Zoom also.
We have a question. Let me answer a question from the remote audience.
Oh, let's see.
Yeah.
I don't see any open questions on the webinar chat.
There's a hand raised.
Who raised the hand?
Oh,
Any other questions?
Okay, no. If no question, we can go with the audience. Yeah.
So I think I missed it. How do you actually add your own domain knowledge to a large language model? Is it only through sending the prompts? Is it all about prompt engineering, or what else does it?
So I described it here. The way you add it, you have to first calculate the distance inside your local document.
So basically, you have to create a representation of your domain, and
Yes.
you have to do it pretty much in a manual way.
You obviously need a
your
large.
web pages.
You don't need a representation. You just need a language model converting the document into a vector
Oh,
representation.
gotcha. So are there some software tools for this?
So you can get from Hugging Face. There are a lot of language models, say Bird or whatever. You just take one language model, convert it.
And if we, for sake of argument, assume that all this domain knowledge is out there on the open web, what is the best out of the box model to use? Is it GPT-4? Is it BARD? Is it whatever? Because there's a model that has the whole internet in it, so that you don't have to train it on any additional.
Sure. Of course, the best is GPT-4 out there based on all the evaluation. That means you send all your documents to the server, OpenAI server, and receive back the embedding. So they have an embedding server there, but it costs you, right? And also it's slow. You have to send all the documents. So many companies decide not to do that.
So GPT-4 has an API for training.
They have an embedding API. Yeah.
With limited
Just-
tokens.
The hello world embedding example, a line ago just to price it out, it was 29 cents to do it once. Their hello world, not your. But if
So this is once per query, or you train it?
to set it up. To get what you have to do. So I just had a comment on this question. Actually, the vocabulary size is different from dimension for each word embedded, right? So it's 4,758, 712, whatever the size of that word vector might be. That's in a separate dimension.
Yes,
So,
it's
yeah.
2 dimension.
Yeah,
One
yeah.
is
Vector
the
size is different.
number of words in the sequence. Another dimension is the embedding size. So it's n times d. D is the embedding size. Come back to the embedding server you are using. You can definitely use what I found is just very expensive. Not in terms of cost, not in terms of money, but in terms of you have to upload your document to the server, wait for it to come back, and also you have to save exactly like their format. If you add additional document to your collection, you have to upload your additional document to, and then you have to recalculate the collection of document to the current query. So so saving your locally, get your local embedding, I think is still the best option. That's why a lot of companies move into the local, their database, their vector database. So maybe I needed to explain a vector database a little bit. So yeah. So the question, so the way you, the question is how do we translate the documents into vector representation, into segments? There's no magical way. We just go through one paragraph by paragraph. Yeah. So if your document is 10 pages, right? You take maybe half page as one unit, and then you do 20 chunks. That's it. You don't know the similarity because each time a user has given a question, right? You are calculating the distance between user query and your document. So, but you calculated the vector representation of the document because you send each paragraph into this language model. The output of the language model is a vector of numbers. That's the token representing the document. The best match, the top match. So you essentially, if you have like 20,000 documents, right? You basically run through all of them, and then you find the top 5 most similar. But so that comes to the question: how can we quickly search 20,000 documents? And that is exactly what a vector database helps you, or the fast search, the FICE, FAISS, the FICE index method. So this comes down to how do you index your vector so that your search is instant, is constant time instead of linear time, right? And that's basically go back to original search technology. Now our technology is built on the vector search.
So it means like when I'm sometimes an on-site remote, every time I want to test this, I technically have to put all of my documents to get it. I don't know what document has the answer for my question.
No. I think you install your local FICE index, or you save all your embedding inside the ChatGPT somewhere. So the ChatGPT solution, I tried only in the beginning once, because later we just decided to do locally. If you do remotely, anyone here use local remote embedding? Very few people do remote embedding. So ChatGPT, no, actually it's this way. ChatGPT calculate the embedding for you. You download, you save in your local database or local file. So when the query comes in, you only send the query, user query to the ChatGPT to get the embedding back, because you already pre-calculated the document embedding, right? So you have a vector for all your documents.
I don't have to approve my document.
Only once. You have to do it once. You have to get an embedding, right? The embedding means the vector representation of that document.
But it is my document and share it.
Yeah.
SharePoint.
You have to convert it into a vector of numbers. That's what we call embedding, and that's the essential part of this whole technology of using domain knowledge combined with large language model, because large language model takes only vector of number as input. Yeah.
I don't know if you want to continue on or.
Yeah, we can go to. We can come back to for questions. All right. Yeah. So maybe this is a good time for me to give more explanation. So this. There are a lot of solutions. So we know ChatGPT, OpenAI support embedding. But many others company provide a cheaper service, faster service, and a dedicated embedding service. So Pinecone is just focus on one task. Just you send your document, they give you back embedding. They host all your document on their server, so you don't have to worry about where your document is. So your user query comes in, they immediately tell you which document is the most similar ones. So they basically do the remote service for you. Certainly, OpenAI also do that, but I don't think OpenAI hosts your documents on theirs. They don't have this hosting solution. So this is one business model where you don't have to worry about exactly how they do it. Every time you see something, you send it to Pinecone server. However, as I said, many company has a privacy concern. They don't want to send everything remotely. Then, so we have this local vector database vendors like Weaviate. The last two is open source one, but they are also vendors you can get help from. What they do is they basically create a new type of a database. That database is a traditional database combined with some capacity to save the vectors. So the traditionally, if many of you work on database, we know a data column has a property of a text, number, integers, floating, date. There's certain specific type of data. So now we have a new type, not a new type, but the type already exists called a blob, which is holding the binary representation of object. So now the whole, because the vector is very, very large, you convert it to a binary representation, and then this particular column is this blob data type, and this column saves all your embeddings. So that's how their this vector database work. So they have a capacity to save your embedding into certain column, and then they also support retrieval, support the insertion. Yes.
You get a chance. There's a couple questions from the web.
Okay. So with this the beauty about this is you can do very fast retrieval because they handle retrieval for you. They somehow index the document for you to quickly match the user query with say 20,000 documents, right? You don't they pre-calculate the index. So when the query comes in, they can immediately find the top 5 in an instant, actually less than 10 milliseconds. So it's very fast. So this is today's solution for this. Yeah.
A couple of questions from on the web from YouTube. So Jogrut was asking, are there recommended prompt size in relation to the size of the documents?
Prompt typically are smaller than the documents because the documents act as a context. The reason prompt is smaller because we would like the answer comes from the context. that shows the answer is unique to what we retrieve. Otherwise, you don't need the context. You just say generic, give me answer for insurance question. That's a very generic answer. So your prompt is guiding the language model ChatGPT to send back some answers. So if you give more room, more tokens to the context, they will guide the ChatGPT to use that information.
Another question from the same person. What if the prompt matches many docs very closely?
Since we do top N, right? We do top 5, top 10. You don't just do top 1. What we found is the minimum you should do top 3. Ideally, top 5 give you better result. That's because sometimes the embedding is not always correct. There are always exceptions to the language model. First, the embedding language model is trained on some other data set. It's not on your domain data. Unless you retrain the embedding on your domain data, it becomes even more tuned to your domain data. Maybe the conversion from the document to certain vectors may not be the perfect ones. So you select the top 5 as a backup.
And then a question from Matthew, a longtime ACMer. Are there many APIs already available that can automatically fold in local documents for retrieval-augmented generation?
That's an API. That's what we talk about. Those database, those vector database. So if you install them locally, you just say load this document, save to database, and they do all the work for you. But you have to tell them which language model you want them to use, a large language model for embedding. They may select for you. However, they always give you option to replace some language model they use with yours. That give you flexibility. Remote API, as I mentioned, the Pinecone is the API based. Yes.
So would you recommend maybe doing like 2 embeddings if you have a specific domain, like one generic embedding for basic language, and then another, let's say medical or legal or something like that, combining those?
Your application has 2 different domains.
So one domain, but for an application, let's say an application in a legal domain, would you like do an embedding that is general purpose language, and then another that is legal?
You can use the same language model because, as I said, ChatGPT is just one single model, and so you use one language model to embedding for different domains because the language model is capturing the word sequence, capturing the property in the words. That's I wouldn't do 2 different embedding models.
And embedding models like a data compression. So if you compress on general language, you are used to compressing general words. And so, if you get into a domain, then if you want to do something very specialized, you could do a legal embedding. But if the embedding is just 1 to 4 characters, you might as well just use general embedding.
But if you want to do much better job to find a similar document, if you want to further fine-tune the embedding model, you can definitely fine-tune it. So that means you take the current language model and do an auto-regressive learning, unsupervised learning on your local documents. So it learns the sequence of special vocabulary like medical terms. And once you finish learning, that model may be smarter. So the output of that model, the embedding will be closer to what you want. Yeah. But that you need to do a lot of research on that to see how large it will change the embedding performance, right? Because the reason is today's language model is so large, it already seen so many examples. So your local training doesn't make too much difference.
An audience question from Tony. If you divide your document into pieces and only retrieve the parts that are specific to the prompt, don't you risk losing the context of the full document?
I think it's possible. So it's
Would you just retrieve the paragraph? Each paragraph has a document name and page number or something?
The context, so for example, if you say like in our example, Steve Jobs, so we ask about the childhood, but the previous paragraph actually talk about the childhood friend, and the second paragraph talk about what did they do together, right? So maybe retrieve the second paragraph and then but so if we do top N, both will be retrieved, right? Then that context will be carried together. That's the top N, the power of top N, not just top one. It's possible, say you cut off at the top 5, maybe the 6 has the context, and that is still unsolved problem. I don't think there is a good solution for that unless you increase your context length. Yeah, so that's a very good question.
That also becomes a hyperparameter of what the chunking size you're using, but you have to evaluate once you retrieve. That will determine whether your chunking size is optimum. And I don't think there's a
there are a lot of work has to be done to decide how large is your chunk, right? The larger chunk you have, certainly you can capture more context, but you can retrieve much fewer chunks, and that lose capability of capture other informations. You do want them to retrieve from different locations to give you a complete picture. And so we normally take say no more than 100 words, each chunk. You don't want each chunk to be too large. The smaller size of each chunk, it gives you better, more concise answer. Otherwise, the answer is not concise. Yeah, you can have many noise in each chunk that confuse the ChatGPT, confuse the large language model. Yes.
I have a $1 billion question. Are there any good examples, open source examples of applications built around those custom LLMs where you can actually see that they are doing something in each other domain that actually is useful, right? And you're not talking, generic ChatGPT prompt wrappers.
Yeah.
Any examples that you can point to in open source to look at complete projects to kind of pick them apart and apply to different domains?
I'm not sure about the open source, but I know many companies build
but that's kind of the challenge, right? It's very difficult to evaluate those things until you actually interact with the application, right? And you have to have access, because there are a lot of people talking about it, right? Mm-hmm. But it's one thing is hear people talk about it versus actually being able to evaluate actual products and see how good they do, right?
That's what we're trying to do with the PDS in a month or two.
So there's going to be some live open source examples. Is that what you're saying?
We're looking into the agenda, but we're looking at hands-on what some of the components you need to build an application. So not do everything, but do what we can in 6 or 7 hours.
My suggestion is, since you want to get deeper into, I would just build it. End to end.
Well, and that's why I'm looking for some examples. And I'm specifically interested in real estate domain. I could think of some specific, questions, problems, yeah. But I would rather start with kind of a turnkey example from another domain. This is where I just need to plug in the domain knowledge, and this is how I fine-tune the model. And this is where I figure out at what point the model becomes actually useful and accurate enough.
There's some pretty short courses on deep learning of AI, including like development with Langchain, take half a day or something.
Just to clarify,
yeah,
this augmented retrieval is not the same as domain training, right? It's just retrieving the appropriate output.
No, there's no training here.
Yeah, no training.
This is a retrieval.
So it's like
there's no fine tuning.
So there are two concepts here. One is information retrieval, which is a classical concept sort problem.
Yeah.
People do it exactly the way they said. You're retrieving it fast, and then you're providing that as a prompt in the context, either 0 shot, 1 shot, 2 shot, so that it can answer your question.
Your backend model is the same. You didn't update the model, but the fine tuning is a total different.
Yeah.
It's a solely focused on the language model itself. Yeah. So this is called the augmented. The previous one we say it's called augmented retrieval augmented generation. All right, we can move on. Next. All right, now good segue into fine tuning. So we find a way to capture the context in our domain document, but we felt the current model is still not sufficient to capture my domain. Like I do want to improve the language model to say back like a chatbot, to say more in a way that more consistent with the personality, like a teacher or tutor. Somehow I have a lot of domain data. So I have maybe I collected some tutoring data. I want to feed into the model so that when I continue to, so I load this model, either you can upload this data to OpenAI for them to do the fine tuning, or you can say if I host a model locally, I will continue to add some data to the current model, say Llama 2, and you can fine tune the Llama 2 with this supervised data set. So supervised data set means you have input, you have output. The input would be a student question, the tutor's response. You combine them together, send it to your current model. Your model learns and becomes smarter because it sees the patterns. And we actually showed in my training class that we have this generic ChatGPT doing conversation, and which is very dull. It doesn't say much. If I say hello, it gives me some like statement of the world. But I want to have a conversation. I want it has a character of a movie character. So we fine tune it with this movie script. After we have the movie script of the character conversation, next time I say hello, it comes back exactly like that character saying things, right? So this is we call fine tuning. Fine tuning is you use additional local data to make it behave like what you want it to behave. And so this is going beyond just prompt engineering, going beyond just retrieval. Retrieval is typically retrieve information from your domain, but the fine tuning is make it behave to speak like a certain ways. That's what the fine tuning is about. Yes.
So when you do the fine tuning thing, you also reduce the size so that you have a smaller model which is more
good observation. If you do local model, you definitely don't want it too large, mainly because the cost. So if you have a lot of domain data and you can somehow make the smaller model become very smart, like what you want it to behave, I think people find that it's possible to do with a smaller model.
But I guess what she's saying is if you start with 7 billion parameter model,
yeah,
you will have to fine tune the 7 billion parameter model, right? It's not as if you're training a smaller model.
Actually, if you have a representative set of beliefs, see how the model behaves, you can prune a lot of the model.
Yeah, there's knowledge distillation, there's pruning, quantization reduces the size of the weights, like from 32-bit to 16-bit or something like that. So there's the same things you can do for image recognition models you can do for language.
If you reduce the precision of the model from 32-bit to 4-bit, that model becomes smaller. However, there's a cost, right? The precision will go
That's
down.
where you get into the pruning or knowledge distillation.
Yeah, ways on the heuristic. These are not other things. There's ways I've seen that people have discussed that. I don't know how to work.
Okay. Yes.
You said you're only retrieving the information.
Yeah.
But ChatGPT is fabricating it. So that's two different.
Hallucination. You are talking about hallucination from large language model. So what is a hallucination? Hallucination is they generate a sequence of tokens that's very plausible. That's very rational, but it never happened in the real world. It speaks almost like a truth. That's because the way they generate token is token after token. They said, given this token, what's the next token that's most likely to happen given the data I have seen so far? So hallucination, it's the property of a large statistical model, because we are just assuming that the token is most likely to happen. But of course, that doesn't get rid of hallucination.
If I ask ChatGPT to write a previous story, then it's going to
I was going to say, maybe we need to limit the questions for a little bit, so we can, about how much time do you think if you're just presenting? It's like 8:30.
So we should end.
Well, we can go on a bit longer.
I'm almost ending.
Okay.
So I have 1 or 2 slides.
That's fine. Okay, sure.
And I think that's a good segue into, let me finish this slide.
Okay.
So I talk about the supervised fine tuning, and then you can also do auto-regressive fine tuning, meaning you don't have corresponding data, you only have a local documents, but you want to improve the vocabulary, how the language model speaks. You want to give them a more variety of ways to speak. So auto-regressive is just sending the whole document as a sequence of text to train the document. And then lastly, you can use a human feedback to build a reward function. So this is the whole methodology that is a different class. So the doing reinforcement with human feedback is you build a separate reward function. For certain kind of answers, you give them positive reward. For certain kind of answers, you give them a negative reward. So once you build this reward function, you use that to train your current language model to become smarter. So the current model will be will learn to say the right thing. And so this is the third method. So this just illustrate how our RLHF works. I'm using the Llama 2 chat more how they actually build a chat conversational model based on their Llama 2. So the first step is they do some supervised fine tuning. So they collect a conversation between human and machines. And the second step is so the major training is here, but they need to build on the upper left is the human feedback, the give you reward function. So you know certain kind of conversation is good or not. Using that, send it to the central on the upper right. That's the reinforcement learning with human feedback, where you use the previous trained reward model to tell you how to generate a good response. And the generation is based on the PPO, proximal policy optimization. Policy basically means the action. What the action here is the token, the word you can select. So what token you should select to give you the best performance. That this is the reinforcement, the fine tuning with RLHF in a very quick high level view. And I think one more slide. The people ask about the local model, how you minimize the fine tuning. So one method is using so-called the low rank adaptation called the LoRA. So in this method, you freeze the current model weights. You don't update the weights. You only add additional weights on the side. So you basically can save the current model without touching it. But understand that you are adding new parameters in every layer. So if your original model has 48 layers, you now have also 48 layers on the smaller adaptation, this orange area. So basically, you have two models. You have original model plus your new called adapter. Adapter is a much smaller model. When you actually do inference, you merge these two. So you have to do a merge so that when the query comes in, you merge the weights together, and that'll give you the output. That'll give you the actual output. The Hugging Face has an implementation called the PEFT, parameter efficient fine tuning, so PEFT. In that package, they implemented the LoRA, so you don't have to worry about how to implement it. You can call that package. Yeah. I think, and maybe I have a demo that I want to, if we have time. But maybe I will skip that today. Maybe you guys can.
Okay with demo.
Just click on it, right?
Go ahead.
All right. This is just some demos, but I want to show you the so-called domain retrieval. If I talk to each of these coach with the same question, the answer will be different. That's because we do use the context of Steve Jobs' speech with Warren Buffett's articles. So each of them give you different advice on the same question, say how to launch a product. Steve Jobs would focus on maybe whatever the product launch, the marketing side. Maybe Warren Buffett maybe say different things about the value, about maybe Paul Graham has a different idea about the launch product. So they each focus on different aspects. One focus on startup, another focus on the product itself. And one thing interesting, what we built is the Tony Robbins. We added a video search inside the conversation. Maybe it's the
That real estate coach, Tom Ferry.
well, I don't want to. Well, it works yesterday when I tested. So I can skip this part. Let's you can later you can just play with this. So I'm not going to show this anymore. Let's it's
announcement after this, we can quickly
If you want to answer another
I think
question.
we had some crash in the back end, so it somehow crashed today. Otherwise, you wouldn't say hello.
Is that a single LLM or multiple training?
It's one LM, the one embedding, but different documents for different coach. Let's share the PowerPoint again. Let me. It's this one? Or back to this one? Yeah. All right, so just the last slide for. All right, that's it. So if you are interested in additional, like if you have a problem with your company or you want some help, I'll be happy to. You can contact me. In the meantime, my company, I'm looking for interns. So if you want to get your hands on, get some practice, and you are very good with basic computing programming, that's someone we are looking for. So that's, yeah, you can email resume to us. Yeah.
Thank you.
Question. Yeah.
Ash, did you want to say something?
Architecture behind the Coach.ai is similar to what I described.
Yeah.
We have a separate embedding from the LM embedding because we want a local, we have a local storage. We have a local embedding. We don't want to send embedding out. Yes. Yeah. To build the product? Yeah. Well, that's very typical for every startup. So
QR code.
we actually tried many different models, many different applications. We tried the corporate training. We tried the, and then later, I think during, we started earlier last year, before ChatGPT. So then we see GPT-3, the power of GPT-3. 2 months before ChatGPT, we actually built this application. And then now people say, oh, everyone can do chat, everyone can do coaching. So what I was going to demo is on top of text, we can do video. We can do video conversation. So there's some additional function you can build. Yeah. Thank you. All right. Are we out of time?
Yeah.
Okay.
You can definitely hang out if
Okay.
you're able to afterwards.
Okay.
We just have a couple of quick announcements.
Sure.
Greg's going to show you a QR code. Just a minute. Think we good?
Yeah, just.
That's fine.
Greg is bringing that up. And then remind everybody that.
Greg, I think it's fine. It's fine if you just show it. It's fine.
Provide the space for us. And that allows.
Let me just
yeah,
share this with you.
So consider, what do you have to know and how to do that?
So a couple of quick questions. So Greg has decades, goes back to things. There's a couple other people who are involved. So we're putting together a workshop, and one of the biggest challenges we found in LLMs, I think it's on a different screen, right? Is that you can't really get hands-on experience because everybody wants you to get, some API key or whatever else or compute and whatnot. So we want to try and figure out a new model. We want to try and give you sort of like a workshop where you can simply go in and log in and start to work on the code. But to set this up properly, we need your help. We want to understand, what are the missing pieces for you. And this is just a simple 4-question survey. Name, email, your interest in LLM. There's a lot of different parrots that you heard about today.
It's not working.
And it's actually really simple. It's a bit.ly link called bit.ly/want capital LLM, right? So you can remember this, but fill it out. And once you have your email, no spam, promise you, but we'll just email you once and maybe twice to remind you with a sign up code. And I think we're thinking like the first 25 people or so that sign up, will give them like a pretty hefty discount. This is a new thing. It's going to be in Hacker Dojo, most likely outside. So you know what the working model looks like full day. And Vienna is great with food. So we'll have some food, we'll have some compute, and we'll enjoy it.
Yes.
Oh, yeah. Sorry,
Yash
I
is
introduce myself. My name's Yash. I'm the current chair. And we have a lot of people here, but we do everything that's basically free of cost throughout the year. This is one or two things that we do that does cost us a bit of money for organizing, hosting fees and whatnot. So we charge for it, but it's very nominal. But sorry, my name's Yash. Greg Makowski will be teaching. Greg Weinstein, Liana, Will Bruns in the back. I don't know if I'm missing any other volunteer, but SI. Thank you.
Yeah, and we have many volunteers that are not here tonight.
Yeah, many volunteers, but we'd love for you to volunteer. I think Umesh was here earlier. If you're interested in volunteer, if you're interested in doing pizza runs or helping with marketing, it's really good. I think it's really nice. This community exists because of volunteers. So please stand up and be counted if you have the bandwidth. Thanks again. Our treasurer is going to pay for it. So please, just help us figure this out so it's beneficial. Can I just have a quick hand? Raise hand. Who's super not familiar with LLMs? And it's like, I'm really basic. I just want to know what this is all about. And I just got to find out about ChatGPT 6 months ago, and that's where I am. Okay. Who's saying that I actually have heard about RAGs, and I think I know what to do with it, other end of the spectrum. And I'm starting to explore my own PDF documents and asking questions from it. Okay. Everybody else is sort of in between, like fine tuning and exploring. Okay. Awesome. Thank you.